All right, this video goes over the changes to the Isaiah lock controller and door controller. This video is November 2023, and this is a custom modification for the Northern California project. So let's turn on the power by plugging this in. And normally if you try to go into the menu on boot up, you go straight to the menu. Now on this change of software, now you have to enter a code. So when you press and hold menu, it goes into a beeping which telling you you need to do something here. So you can scroll through the 4 digits. Let's see if I can get this to focus. Scroll through the 4 digits, if you can see that cursor. And let's put the code on, press yes and no or up, down. Put the code on 2222, and it lets you straight into the menu. So now you're in the menu just like you would normally be. Now if you want to change the code, it's towards the bottom. If you go all the way down to the bottom, that's where your diagnostics, all your inputs are. Go up one step. And so now we're on change code, and we're going to change it to whatever we want to change it to. Let's try 3333. Press enter. And it beeps at the end telling us that we've changed that code. So now the code will be 3333. That won't be the default code in the system, but that's just for my demonstration. So now the motor is homing. So we pretend like the door just hit the strike site jam. Okay, now that I've already put in the code, I can go into the menu anytime I want because I've already unlocked the system. Now after some amount of time, it would be, I don't know, it would be quite a few minutes, it will exit the access, in which case at some point you'll have to put in the code again, and you'll know if you have exited because you'll go here to access the menu, and then it'll ask you to put in the code again. You'll see all zeros, and it'll ask you to dial in each number. Okay, now another thing that changed on this version of software, and you can see this is the Isaiah lock type, wait on unlock. So I changed some names of some features in here because they were a little bit confusing before. Wait on unlock. What this does is if you tell the door to open, the first thing this does is send out a command to the Isaiah lock to tell it to unlock. And then this software waits on the Isaiah lock to actually unlock. So it has some lock, LK, I think it's LKS lock status. So we have a relay coming back from the Isaiah lock to tell this system, yes, we're unlocked, now we can open. It has to wait for it to open. So this is the amount of time in milliseconds. It's actually not exactly milliseconds, but think of it as this 2200 processor counts. So it waits for some amount of time for the Isaiah lock to actually do its process and unlock, which could take a second or so. Then there's another feature that I changed to make more sense. Unlock wait to open. So after the Isaiah lock starts moving, it's a motorized system. After it moves a little bit, it actually hits a relay inside of its own lock system, and that relay tells this system that it's unlocked, but the pin may not be all the way up. So we give it another little bit of time, 1500 milliseconds, to wait for that latch to finally get released. Then the door will open. Okay, so it's two different things. One is wait on unlock, which means we send a command, tell the Isaiah lock to unlock. This is how long we're going to wait on the Isaiah lock to do its thing before we put up an error and say it didn't work. Okay, I'll demonstrate that now. We're showing that the Isaiah lock is in the locked position. This is simulating Isaiah locked and unlocked, okay? So let's press open. Let's find an open button here. So I'm trying to simulate all the inputs in the real world. Press open and watch what happens. Send unlock command. This system just told the Isaiah lock to open, but it didn't open in that certain amount of time that I showed you before, which was called wait on unlock. Now, what I'm going to do is I'm going to simulate, and you can tell that I'm sending out the command. Watch the LED here, open, and then we press the unlock. Now the door opens, but there's some synchronization that must take place, otherwise the motor will be trying to pull against the pins in the latch, okay? So now we are open we're unlocked. If you, for whatever reason, the lock became locked and you tried to press close, nothing will happen. It will not let you close the door if the latch is latched, because then the door would slam into the pins. So it must be unlocked. Then you can press close. The door starts to close. And when it gets closed, you can see I changed these LEDs as well on this software. So now when the door is closed, door status, it's not easy to read there, but DS means LED on. The red LED on means door status, the door is closed. If I press lock, simulating the Isaiah lock being closed, LS is lock status, and that says that the lock is locked. So red means locked, door status, LED on means door is closed. Whereas on the older systems, I had it in reverse. I think it's a little bit more intuitive to have locked be LED on and door closed be LED on, okay? And those LEDs correspond to the relays. So this is a relay, and you have a V common. Right now for the V common, I'm just using 12 volts here coming in from, I grabbed a 12 volt terminal somewhere, and we're going into our V com. Then the lock status out would let you take that screw terminal out to some automation system or monitoring system, and door status, you could go out there. Now, it may be hard to see here. Let me see if I can do this. Down here, there's a relay that's been added right here. There's a connection here. What that connection is for is one of the custom features we just did. Sorry for all the noise. That feature is monitoring whether the door is active and running or if there's a problem. So if the system is up and running, that contact will be closed. So it'll be a pigtail coming out of there, 2 wires that you'll run to your monitoring device. And as long as this relay is closed on here, your system will see that it's closed, and it's a dry contact. So you would send it a voltage and you would monitor your voltage. Okay. Other than that, those are the changes basically. Something that may have changed is a holdover from some previous versions. You have a stop button that if you press stop while it's moving. So let's just simulate. Also, if you unlock the Isaiah lock from any other button, you may have home automation connected directly to it. You may have buttons connected directly to the to the Isaiah lock, or keypads connected to it that are unrelated to this system. If the Isaiah lock becomes unlocked, unlock trigger in, the door starts to open. Now, the unlock is built into this system, whereas on the other system, we had to do an unlock mod. So on here, the unlock opto is built onto the board, whereas on the older board, we had a board called a unlock mod added to it. And you have a voltage coming in. This purple wire is 12 volts, but this voltage coming into this relay must be coming from the Isaiah lock, from its own 12 volt power supply, because of the fact that this switch is connecting to other inputs on the Isaiah lock, and it may have other buttons and other keypads and other things. So it needs to have its own power supply. So don't mix the 12 volts on my system here like I'm doing to go to feed the Isaiah lock, because the Isaiah lock might have 12 or 24 volts. It could be another power supply, and you could potentially be slamming 2 power supplies together accidentally. So this purple wire going into the unlock in is going to come from the 12 volts on the Isaiah power supply. It comes out of here, goes into a relay, comes back out. This red wire, I've got it going to an LED, okay? This is going to go back into your unlock opto in, or the Isaiah opto in. All right, other than that, I think that's it. I don't have a wire connected to this relay, to this pin here, these 2 pins. I don't have anything connected to that now to demonstrate the door status, or the I don't know what the right term is, door active or door functioning properly status. We'll come up with a name for that later. But it's just 2 wires. They connect. I'll put a pigtail on here with that connector. You'll connect that to your system, and then on boot up, the system goes to its processes, and once it gets through the boot up process, it turns on that relay. If there's ever a fault, it turns off the relay. If there is a closing trip level, it does a momentary closure or a momentary disconnect. So it's already closed, so it does a momentary disconnect for 1 second and then goes back, so that at least that way that the monitoring software can see that it did have some event, like the door hit something and retracted. So that way the monitoring thing can know that something happened, but it did not shut down the system because the signal went low and then went back high again.